So I think I can start now. So hello everyone, my name is Kaushiki and I am a PhD student in IIT Bombay. And today I'll be taking a hands-on training on introduction to Sklearn using Python. So I have provided a link in the message chat box. Please go through that link and make a copy of that, and so that we can do a hands-on training for that. So I'll be sharing my screen right now, and please confirm me when you can see the screen. And again, you can interrupt me anytime. I'm not able to see the chat messages because I'll be sharing my screen. So feel free to ask me any question anytime. Just interrupt and please speak up. In case if you and I, any of us drop out, please join again. Please confirm any of you if you are able to see my screen.
Yes.
Okay, great. So today we are going to do a hands-on training on introduction to Sklearn. So Sklearn stands for Scikit-learn, that is SCIKIT. Scikit-learn is the most useful and robust library for machine learning in Python. It provides a selection of efficient tools for machine learning and statistical modeling, including classification, regression, clustering, and dimensionality reduction. So, Python is a programming platform, and this sklearns help in providing a efficient tool for this machine learning. This library, which is largely written in Python, is built on NumPy, SciPy, and Matplotlib. So first step is would be we will be installing Scikit-learn to our platform, and the uh, screen I'm sharing is called Collab. So Collab is a online platform of Google which provide Google Cloud. That is, you can run your Python programming without depending on any variables. So what does variable means is, so for Python, there is need of some variables which needed to be set. Like it works in certain environment variable. So first thing we will do is we will install Scikit-learn. Um, I would recommend you guys, just instead of seeing on the screen, just make a copy of that so that you can simultaneously work on it, and wherever you guys are having any problem, we can together go through it. So if you can
Excuse
see,
me,
yeah, please.
can you please share the link?
Okay, I have pasted in group if I'm not wrong, like in the chat box. I'll do it again. Yeah, is it fine? So just go through this and make a copy of it. So to make a copy of that, you have to go to File and save a copy in Drive, and then you are all ready to go. Or make a copy of that. Anything is fine. So should I wait for 5 minutes or should I move ahead? Please let me know if I need to wait for you guys to make a copy of that and start, or should I move ahead?
You can move ahead.
Okay,
Just wait.
yeah, I'll do one thing. I'll wait for a minute and then we can move ahead.
I have one question actually. If someone is having Jupyter Notebook over here,
Yeah,
so can he download this as a Python notebook, the Jupyter Notebook, and then open it in that?
yeah. See, Jupyter Notebook, the collab have actually a Jupyter Notebook, in the background. But
Hmm.
this thing to import on Jupyter Notebook, you can do it. But again, there will be issue of environment variable. Not always, but there can be. So what is the advantage of collab is You don't need to take care of any environment variable or any, because certain libraries work at certain environment variable. Which I meant is, uh,
Okay.
collab updates itself automatically. So if I want to use a particular version of Python or particular version of a Python library, I don't need to update it. It will automatically update itself according to the requirement, which is not in the case of Jupyter Notebook. You have to do it manually. So I usually recommend Collab until unless you have to deal with a huge amount of data or programming, because there's certain limitation on Collab when it comes to RAM and disk. You if you can see in the right hand side top corner, you can see RAM and disk. So that is a restriction. You have a restriction of 12 GB RAM and around 107 GB of disk. That much space you can get it. So yeah, I would recommend you to explore this collab, and then obviously you can go to Jupyter Notebook and again try this programs. So that's not an issue.
Okay. Got it.
Okay,
Thank you.
yeah. So moving ahead. So first step would be, let's install our Scikit-learn to our collab. So using that, I have installed my Scikit-learn. Second step would be, I have to import it. Even after installing, I need to tell uh, my programming command that I need to import it. So I'm importing sklearn. There's something called pandas. It's again a library of Python which have certain advantages. So I'm importing pandas as PD. So yeah, let's execute that. So over here, if you're not familiar with Collab, I would like to tell you this play button is where you have to click to run the cell, that particular cell. And even if you can just shift and enter, it will be like run. And these are the text boxes which I have written for clear justification. Okay, so after doing that, I can see my sklearn has been imported and my pandas has been imported, which is termed as PD. So why I have done import pandas as PD? Because every time writing pandas would be bit tedious. So what I have done is I have just written it as PD. It will be convenient for me when I have to call this function or library. I just need to mention it as PD. I'll show you where I have used that. After that, I'll be moving forward with, after importing sklearn, we had importing our data set. So there are some standard data set that can be used, any data set. Over here, there is one data set called iris, iris, which is a set of flowers data set. Like there's one flower named iris. It and its data in the form of its size of stem, leaf, flower petals, and other relevant data has been stored, and it's available freely. So what I done is, this sklearn dot data set. It's a by default function from sklearn. I am importing a data set called load iris. This is a already defined data set. Oh, in place of load underscore iris, you can use any data set which you want to. But for that, you need to inform them that this is the data set you are using. Okay. So let's, and one more thing, whenever you will execute any cell, you will see a cross, like a tick mark, a green tick mark. This means there's no error in your programming. If there's a cross mark with a red, you can see a error. If you want to see an error, I'll just show you one error, how it will be. So moving ahead, I am defining a temporary.
Hello, ma'am.
Yeah, sure, tell me.
At the place of PD as our convenience, can we use anything else, or it is compulsory
Anything,
that PD is
no,
there?
that's what I'm saying. You can even use P instead of just PD. You can use P,
Okay.
PN, any variable. This is just what I have defined. So I'm just calling, like, I want to import pandas as PD. This is more of like when we are we give a nickname to a person, right? So if a person's name is very complicated, we will just give a nickname as our convenient. We want to call that person as that name. but we need to inform that person, right, that I would be calling you afterwards, not this name but this name, right? So that that person would be knowing that we are calling them. So similarly, like this, we are telling pandas that we will be calling you as PD. Okay, so this is what import pandas as PD. So if you'll see in this cell, I'm giving a name IRIS. This also you can give anything like IRISS. This is a variable. Variable means you that can be defined as anything, like in any scenario. Load iris is what my function, like my data set is, which I have already imported, right? So I'm calling that. Again, this is a variable df iris. So df, I'm telling data set, data frame. So I'm telling just load my data frame iris. And how I'm going to load my data frame, what does data frame means? So the data set which is load underscore iris is having so much of information in it. So that information when is retrieved or which is called, that is in the form of frames one by one. So that is called as data frame. So for that I have given a variable df underscore iris, and now I'm using pandas as PD. So that's why instead of using pandas over here, I'm writing PD dot data frame. I'm calling this data which is iris dot data. So this is what I have done over here. So IRISS means it will call this load iris. Okay, column is equals to, now I have to define, because what I'm telling is the data which I want should be in the form of rows and columns. Okay, so why I need the data in the form of rows and columns? Because when we deal with data analysis and data visualization, they need to be in the form of matrices. If we go back to our previous class where we have learned linear algebra, this is where these things come into picture. We were calculating how rows and columns, determinant, and eigenvalues, eigenvectors. So every data must be represented in form of rows and columns. So I'm defining my column irises dot feature name. So I'm telling that column should be feature names. Okay. So if I load it, yeah, it's done. If you want to see the error I told you, right? So for example, instead of load underscore iris, let's write it just iris. Now this variable IRISS doesn't know what IRIS, just this function is. Okay, he doesn't know because there is no function like this. So now if I run it, there will be an error. Can you see the error? Now it's red. The best part is you will see what error is. They will tell you what error is. So name error, if you can see this line, it's showing IRIS is not defined. That's true. I've already told we have not defined it. We have not told this Python what is this IRIS. What they know is there's something called load underscore iris. How they know there's something called this? Because Sklearn dataset already have this data with this name. Okay, so that is how we get the error, and that is how this error has been mentioned here. So if I again have to write load underscore, yeah, now if I run, so now it knows what this IRISS iris means. So it is a green thing. Now the next part will be, I need to see the data frame which has been called. So in 6 cell, number 6 cell, we have already called our data frame and we have already defined what the columns will be. That is features name. Okay. Now I need to visualize my data. What does my data will look like? So there's something called head and tail. What does this head function and tail function means? Head means whatever the data is, like if I'll tell you the data is in the form of 10 cross 10 matrices, which means there'll be 10 rows and 10 columns. Or let's increase it to 100 cross 100, which means there'll be 100 rows and 100 columns. Among them, I want to visualize some 5 values. So this, if you see this bracket is empty. This means by default, if you will run this line, by default it will show you top five data from starting from 0 to top 5 data. It will visualize you. Okay, so when I run that, so top 5 rows and columns, it will give me rows and columns. So if you see 0 1 2 3 4, and I have already defined what I told, like initially, if you'll see the columns, what the feature names. So these are my features: special length, special sepal width, petal length, petal width. These are my features. So these are columns. Now if I want to I want a particular number of data to be seen. For example, let's say 7. I want to, right now there are just 5 data, right? Now I want to see 7 datas in this visualization. I just have written 7. Now see, so now there are 7 data starting from 0. So this is how we can put the number of data. If we not just put any data, by default that is 5. Okay, so let's go with 7 itself. Okay, so we have the data. So head means from 0 the number of data. Again there's something called tail. So what does tail means? What tail will show the last 5 datas. Again, head will show starting 5 datas. Tail will show last 5 data. As the name specifies, the tail means the end of it. Similarly, in this also, if you want to visualize more than 5 data, like by default, if you have not written any number, it will give you 5. If you want to visualize 7 data, again, you'll write 7 in the bracket and you can see the 7 number of data. Now you can see these are the last 7 rows and columns of the data. Okay. Please let me know if you guys have any issues in between any time. Now there's something called data types. So what are data types? So data can be in form of anything: integer, that is whole numbers; float, that are decimals; or long, and there are other different data types. So I just want to know what kind of data types does it have. So if you see, these all data are in decimal. Okay, so this means the data type should be float. So let's see, if I write df iris, which was my data frame, that is data frame dot d types. This d type will show you what is the type of the data. So if I run it, I can see all my column features are d type float. You can see float 64. This means they are all in decimal, which is true, which we have already visualized, right? Why this is needed? Because when we go for algorithmic or other computation or operation, we need to keep it in similar data type. For example, if I'll ask you to add I'm so sorry, if I'll ask you to add 1 plus 3.2 for Python programming, it's not possible because there are two different data types. How? 1 is just an integer, 3.2 is just a float. Now if I'll convert 1, or if I'll write 1 as 1.0, now this is a float and 3.2 is a float. So if I want to add these two, now this is what the Python programming is able to add. So this is why we need to know what kind of data type it is. Moving ahead, this was how we deal with the data, like to know the data, what are the content of the data, what are the types of the data, how to import the data. So this is what one portion is. The next portion is data visualization, how to see the data in terms of plots and matrices and all. So before that, please let me know if you guys have any question.
Hello, ma'am.
Yeah, please.
Actually, I have a doubt. So,
Yeah.
Scikit-learn is a library, and you're teaching how to access it, right, ma'am?
Yeah, I'm just telling you how different types of Sklearn, like Sklearn library, have so many different methods, or different libraries itself. So one library I showed you was pandas. So using pandas, we can import the data frame. Okay, so this is how I showed this. Now there's something called matplotlib. That is also a library of Sklearn or Scikit-learn. So now I would show how using matplotlib we can plot the data. We can plot our data in form of any kind of plots, linear, non-linear, scatter plot, any kind of plot we can do that. So moving
Yes,
ahead.
yes,
Yeah,
ma'am. Okay, but you showed some data regarding that sepal length
yeah.
and all. So, like that, that is also contained in the library, right, ma'am?
Yeah, exactly. So this data is already defined data. I have just taken the example of this. You can import any kind of data in this. I have just taken the
Oh,
already defined data, which was already in the Sklearn. You can take any data. You can take
okay.
your own data and import it.
Okay, this data can be defined by us also for any type of.
Exactly, exactly.
Yes,
So
ma'am. Thank you.
yeah. So over here with where I have, imported this load iris, instead of that, see, I have just directly imported this data from sklearn data set. So sklearn by default have some sample data set, which is among them one is load iris. If you want to import your own data in this cell itself, remove this and just define your data set wherever your data set is and just call it. So you will be
Yes, ma'am. Yes.
getting that example as well in future. Don't worry. Okay. So data visualization.
Ma'am,
Yeah.
how to use a data of EDF file or
Yeah. That's what I'm saying. So over here, I have imported the data from sklearn data set. So instead of
yes,
that,
ma'am.
you have to import your own data set where you have to just define your data set. So for example, if load iris was your own data set, so instead of this you have to write load iris is equals to wherever your data set is, that location, and then you have to call it. That's it.
But for the EDF file, is there any software the library we have to install?
For which?
EDF file,
EDF?
EDF file, extension EDF.
Okay, you meant
If
to .csv file.
I don't have a CSV file, I have a EDF file.
Yeah, so in PDF also you can just convert it for.
EDF.
Okay, I don't know what EDF stands for,
Uh,
because any kind of, that's what I'm saying.
European data file.
Okay, maybe I am not aware of this .edf file. What
Okay.
I meant to say is, if we want to import any kind of our own data, we can
Yes, ma'am.
obviously import it.
Hmm.
There would be something for .edf as well, which I'm not aware, but I can tell you for .csv file.
Okay.
.csv file is exactly how the datas are available in our Excel sheet, that is rows and columns.
Hmm.
So usually datas are imported and visualized in the form of rows and columns. That is how Python deals with. So if your data is in whichever format, that should be in the form of rows and columns.
Okay.
Okay. So data visualization. So from pandas.plotting, so pandas, again I'm using pandas.plotting, we are importing scatter matrix. We have to use scatter matrix. And there's something called matplotlib. So matplotlib is again a library like pandas in sklearn, from which I'm importing pyplot. And I'm importing pyplot as plt. Again, I'm giving it as a name because every time writing matplotlib.pyplot is very tedious. So I just want to call matplotlib.pyplot as plt so that I can use it anywhere. Now scatter matrix, this df underscore iris was my data frame where my data was stored. And I have given the size of the figure. You can change the size of the figure according to you. I have just given a square size that is 10 cross 10. That is 10 centimeter width and 10 centimeter height of my image. When I have done the plot.show, you will see for each features, you are getting one data. So this is my sepal length. Your visualization is done. Sepal width, sepal length, and this data set which is being visualized is, again, if you'll see, it's in the form of a matrix. So if we'll consider this as row 1 column 1, row 2 column 1, like this. So it's rows and column. So the middle one is the diagonal one, which is having the values in the form of histogram.
Yeah, I have one question over here.
Yeah, please tell me.
Why are we particularly using scatter matrix for this
Oh, no,
example?
no. Yeah, you can use any kind of plot. Tell me a name, I'll just do that. So it's not required that you have to use the scatter matrix. It's
Hmm.
just I want to show how the data can be visualized. I have used the scatter matrix.
And okay, like, and as you can see over here, like the y-axis is populated like with the label. So is there a particular label for x-axis also with
Oh,
respect to graphs?
yeah. So the x-axis is having the values, right? So see, if you will see sepal length again, sepal length. So what this visualization is, if you see, okay, I'll go to the data set. So okay, if you'll see this, so for 143 row, there's sepal length 6.8 centimeter, right? Sepal width 3.2 centimeter. So over
Okay.
here, my this visualization, what is done is, so they're taking this y-axis as all sepal length, sepal width, whatever it is. Similarly, the x-axis like this. So that
Hmm.
is how they have plotted the if you'll go to the scatter matrix, how scatter matrix is plotted. So one row and one column. So petal width, if I'm taking the values of petal width, I'm keeping sepal length as constant. So
Con-
similarly like this, the plot has been made. So this is just for the comparison and visualization purpose. There's no interpretation of that. I just wanted to show you that your data, which is in the form of a matrices, can also be visualized. That's it.
got got it. Thank you.
So moving ahead. So right now I have showed you two libraries, that is pandas and matplotlib. So pandas we have used for calling our data frame in the form of rows and matrices. Matplotlib I have used to visualize my data in the form of any graph or plot. Now there's another library, that is Seaborn library. So why Seaborn library I'm using? Because this can do a pair plot of all the features. So what do you mean by pair plot? I'll tell you. This is what pair plot is. Like it is if sepal length is in x-axis, then petal width is in y-axis. Okay. So if I go through, this is another type of just a representation, and I wanted to tell you that instead of that boring scatter matrix, though you can just visualize in some creative way using different kind of library. And so I have used Seaborn. So if to use any kind of library, we are importing it, right? Like we have imported pandas as pd, matplotlib.pyplot as plt. Now we are importing Seaborn as sns. You can take any name. So this name sns or plt or pd is just a variable. You can take any name, but remember to use that name itself anywhere wherever you are using. So I've imported Seaborn as sns. Now sns.set, I'm using this ticks. This ticks means it's just I would like to tell you how, when we create graph, or when we make a uh, plot in our Excel sheet. So we do so many of creativity that our x-axis should look like this. There should be tick mark. There should be this kind of colors. So using Python itself, we can do this kind of creativity. One thing which I have done is style is equals to ticks. This means the x-axis or y-axis, you can see a horizontal, small horizontal line is coming out. That is what ticks means. I just wanted to bold it. If there's no necessity of this, you can totally ignore it or remove it. Again, color codes is equals to true. So what I meant is color codes is equals to true means you can see different kinds of color over here. So I'm telling I want my plot in different colors to identify it. See, if I'll go back over here, I have not done this. I have not used, this is just a simple visualization. I'm like, whatever default you have, just present me a visualization representation. So you cannot distinguish between them, which is which is which, all are blue in color. But over here I want to like represent it in a some soothing way. So this is where I have used color codes. So different kinds of color is, they can take any colors. So you can even mention some particular color if you want, but right now I have till color code is true, which means you have to take any color whatever you want. I'm loading the data set, and I'm doing the pair plot where I'm giving it as at species. Just I have given the name species. So when I run it, I'm having this. So this is my graph. So this is just a representation of graph in a better way. See, so now this also have a label. I have given this label, right? Species, I have told I need a label. So you tell me which color is what. So they are telling in species, the blue color is setosa. It's just different kind of petal data set mentioned. That's it. It's a way of representing your data in a good way. Again, I've shown you can even use a color palette. So what color palette is, I have used color palette as HUSL, which means I can give different kinds of colors. So over here, the color, like over here, I have not defined the color palette. I've just told whatever you want, you can take it. So they took it blue, orange, and green. In this, I have defined a color palette where I have mentioned that color palette as HUSL, which is a USL color, which gives us the RGB colors, which is like usually represented as. So that is just a way of representation. That is nothing different. Okay. So any question in data visualization? Then I can move forward.
Ma'am,
Yeah.
is it just like a confusion matrix, this plot with?
uh you can say that, like, okay, so confusion matrix is more of true positive, true negative, right?
Yes,
Where you
ma'am.
have to say, but it's not that true positive, true negative, it's just a comparison between every species and their
Mm,
counterpart. So you can took it in that way as well, but it's not exactly, not in the terms of values, just in the terms of representation.
represent. Okay.
Okay. Is it fine?
Yeah, ma'am.
Yeah, okay. So moving ahead, now whatever we have done is we have called our data, we have visualize it with different means. Now we have to prepare our data. So what I'm going to do is, now I'm telling you how my data can be labeled and classified. Okay. So before we start with the machine learning model, we need to convert the data into NumPy arrays. What do you mean by NumPy arrays? So right now, which I showed you my data in the form of data frame, that was just simple rows and column. Array will be consider a box, a 10 cross 10 box, where just there will be representation of numbers. So for that, there is a library called NumPy. It's also a Scikit-learn library. It's a very important library, NumPy, and I'm calling it as NP. What does NumPy do is it converts numbers into arrays. Okay, what does array means? Representation of any numbers in matrix form. So giving that, it has been done. So my data frame has been loaded as arrays. Now, what I'm doing is I am doing a pre-processing of my data. So this is from this point, I have started using machine learning model. So I have to go to machine learning model. I have just started preparing for it, pre-processing of that. What kind of pre-processing? So I need to put my data frame into a array. Then I have to do the label encoder. Label encoder means every features should be encoded with a number, that is 0 or 1. How would machine tell, okay, if I want to say the cats and dogs, if you have to differentiate between cats and dogs, or you have to classify among a picture which is cat or which is a dog, it will not say as a name until unless we define it. It will always take in it as 0 or 1. So we have to tell the labels which is given, like sepal length, sepal width, into a number. Okay. So this is what we are doing in label encoder. So there's in Sklearn there's something called pre-processing and label encoder. We have imported label encoder and we have given label encoder as name LE. And we have transform the our array into labels. Okay. So now we also have an an add-on, which is if there is some features we don't need. For example, how can we define? We define according to our need. Like there are so many different features like sepal length, width, petal width. But for example, if I want to do a classification just on the basis of sepal length and width, or petal length and petal width, so we don't want sepal length and sepal width. We just want to classify the data on the basis of petal length and petal width. Sorry. So we can drop these features as well. So over here, I'm dropping my features, sepal length, sepal width, and species. I don't need them. I'll just drop them. I just want to work with petal length and petal width because the data set is so much, and I don't want to, you know, um, make my data set complicated. So I'm just dropping sepal length, sepal width, and species, and I'll be just using petal length and petal width. Now coming back, I have again put all my data set into another variable, that is df selected one. This means in df selected one there will be only two parameters or two features, petal length and petal width. Now df features, again I have defined something, and I'm calling this df selected one, which is having just petal length and petal width, and I'm calling it to a dictionary. So what does dictionary means? So in general, our dictionary will be having everything sorted, right? From A to Z, whatever things you have to find. Like if I'll ask you to find the meaning of a particular word, you can find it based on its alphabetical order. Similarly, in this, dot dictionary means it will segregate the data set according to either ascending order, descending order, or whichever order we want. So, or there is a by default order which is ascending order. So I'm just calling key segregate my all the features or data in our dictionary. Now I am extracting the features. What are the features? Petal length and petal width into dictionary vectorizer. Okay, dictionary vectorizer means I want to import those datas into a particular format. Why I need to do? To make my things easier, because when I'll be performing machine learning model, that would be helpful to me. Okay, so when I load it, yeah, so it's done. I have done all the pre-processing. So this step which I just did, that is 16 cell number 16, this is a part of a pre-processing feature step where I need to convert my data set into array, orient it into a particular dictionary, import it dictionary, I have to vectorize it, and that's it. Next, for any data set to classify, there's something called training and testing. What does training and testing means? I hope many of you must be knowing. I'll just explain it in one line. So, for example, if you need to tell a person who doesn't know anything and you need to train them. So, if you need to identify them what a dog is. So, every time you will tell them whenever you see a dog or different breed of dog or different species of dog itself, you will tell them if you see these kind of features in anyone, that is a dog. That is a dog. So, you are training them. And after that, you will take that person and similar to that kind of feature, that dog can be of any breed, other breed, and you will ask that person, okay, tell me now what is this. So he should be trained enough to tell that that is a dog. So what you did it at a later stage where you ask them what this feature is, that is what called testing. Similarly, in our Python programming, we have to do this. We have to train our model. What is model is what algorithm we use to classify our data. So the benefit of Sklearn is, the best benefit of Sklearn is Sklearn have by default models inbuilt in that. We can import those kind of model directly. We can assign the training and testing. So for that, if I have 100 set of data, like 100 data is there, which tells on the basis of different its features and methods, it tells okay, this is a dog, this is a cat. It differentiate. So for to train a person, or in our case to train a program, we will split, that is we will divide our data set, that 100 data set, into training and testing. So to split that, we can do any number of data. Over here, see, this is what I have done. I am calling a function called train test split from my Sklearn model. Okay. Now there is something called feature test, label test, which means I'll be training my features and training my labels, which means, for example, if there is a dog, so I'll train a person that if a thing have, four legs, two eyes, one tail, something like this, that is a dog. So explaining its feature is feature train, and labeling its name that it is a dog is a label train. Similarly, to test that, feature test and label test. So I'm splitting my training and testing, that is 100 data set. If I have, for example, 100 dogs features, or different species are there, to tell a person to identify what a dog is, I'm splitting that 100 types of dogs into some ratio. So over here I have taken 80% as training, which means 80% of the dog, or 80 dog features, I'll be explaining, okay, this kind of features is there, then this is a dog, this kind of feature is there, then this is a dog. And 20% I'm telling it as a test. Among, so I'll go and I'll show him other 20 remaining 20 dogs, and I'll show, now tell me what it is. So that is what testing I'm done. Okay. So this is done. Now the model which I'm using is called support vector machine. So what support vector machine is, you must have learned. If not, then don't panic. Just right now I cannot explain you what SVM is because it's a huge topic. I can just tell you that think it as a model, or a algorithm which is used in machine learning to classify any object, to classify any features. That's it. So I'll be using the term SVM or SVC. SVM, support vector machine. In that there are two types of algorithm actually. SVC means support vector classification, and SVR means support vector regression. Now, if any of you have doubt what classification and regression is, please don't break your head. We'll get to know in other classes if not yet. But right now, just remember that SVC is an algorithm model. That's it. So we'll be using that to classify our data. Now in this, I am calling SVM and importing my SVC, that is support vector classifier. Okay. There's something called kernel. Again, this is a technical term, and it's a part of a model. So I'm keeping it that kernel as linear, and I'm putting all those my feature trains and label train, because this is where I have to train my model, right? And this prediction part is important, where I'm going to ask that person, now tell me if you can predict a dog or not. So that for that I have given the feature test and label test, and to find the accuracy, how accurate it is, so that I'll be doing in the terms of score, that is again feature test and label test. You, if you have to find how accurate it is, you will do in, you will do when you will be asking him, when you will be testing him, right? So that is where we have selected feature test and label test. And then we are finding how accurate our model is. So over here, test accuracy is 1.0. 1 means it's 100%, which is not always the case. In this case, I just wanted to show you how the test accuracy differs, and our model is like completely, trained. That accuracy can be anything. So if now you have to compute the accuracy using train set. So over here again the same thing, but you can see the training accuracy have decreased to 0.958, right? How this have done? Because now again you are doing the prediction on the basis of what you have trained it for. Okay, there are two things: you are testing, you are training. So you are getting different kind of accuracy. So this is what our classification means, how we classify our data, how we classify our object. Okay. Okay, so let me know if you guys have any issues till now.
Ma'am,
Because
I have a doubt.
yeah, please go ahead.
Ma'am, when you were using the testing data, it gave the accuracy as 1, but
Yeah.
we trained our model using the training data set. But why did the accuracy on the training data set reduce to 0.95?
Okay,
It should
so
have given.
okay,
Yes,
I'll
ma'am.
tell you. So why at test accuracy it is giving 100%? Because I was taking that example of a man where we have 100 dogs, and in 80 dogs we have trained him that okay, this if you see this feature, this is a dog, and remaining 20 we are going to test him, right? So what if I will be just change the scenario? What if I'll be training him on those 20 testing data set? Like, forget about that 80 dogs. I'll just take that person. I'll tell, okay, these, can you see these 20 dogs? If you see these kind of feature, this is a dog. Now again, I'm taking him to those 20 dog itself where I have trained him, and I'm asking him, now tell me which is a dog. So obviously it will be 100%, right?
Yes,
I'm
ma'am.
training on the same data set, I'm testing on the same data set. So that is why my test accuracy is 100%. Now
Ma'am,
change, yeah,
ma'am, but the thing is, like, you fitted the data on the training data set only, not the testing. In the
yes,
example, yours. Yes,
yeah,
ma'am.
yeah. Please go ahead. Hmm.
Ma'am, in the example you said that now you will be telling the dog to see these 20 dogs.
Okay,
Okay, so then we are getting 100% accuracy because you trained your dog on the testing data set. But here you have trained your dog on the training data set, so it should have given 100% on the training data set. That means 80 dogs he should have recognized fully, and that 20 he should have given less accuracy than
okay,
the
okay.
test.
So I'll show you the difference. I got your question. I'll show you the difference. On my screen, both of them are visible: test accuracy and train accuracy. So in the
Yes.
test accuracy, if you can see, I have fit the data using training and both the feature train and label train. But when I needed to predict, I use feature test and score test itself, right? But in the training data set, what I'm done is I'm fitting on the training itself, I'm predicting on training, and I'm doing the scoring or accuracy on training itself. So obviously, in that scenario, my accuracy will be decreased, right?
But you trained on the training data set, you predicted on the training data set, and you are scoring also on the training data set.
Exactly. That is where the error is. That is where the error is. That is what I want to show. Over here,
Oh,
100% accuracy is because I am predicting on the, like I'm fitting my data on the training, but I'm doing the prediction and scoring on the testing data set. Over here, this is what it is wrong. You know, this 95, it is wrong. I'm doing training on the, like fitting on the training itself, predicting and scoring as well on training. This means my data set is either overfit or underfit.
okay,
There's a
okay.
term called overfit or underfit, which we will
Yes, ma'am.
come to. I just wanted to show you this example. This can also happen where you will be using just training data, but that is not how we do it. We
Yes,
have to train our model on the training data set, but when we have to do the prediction, we have to do the on testing data set, which the model have not seen those data, right?
yes, ma'am.
So
Yes,
that
ma'am.
is where I wanted to show. Am I clear now?
Oh, yes, ma'am.
Yeah, okay. So okay, so again, this is, I just wanted to show this different kind of data where I, okay, this is one thing. There's something called shape. So if you want to know what kind of shape your data set have, again, taking just the example. So I've taken again different X train, X test. This is same. You can take it as feature train or label train or X train, Y train, anything. I just wanted to show you if you need to know the shape of your data set. So this 105 comma 4 means, this dot shape means it is printing the shape of this training data set. Okay, and 105 comma 4 is, this means number of rows and columns. So this is the shape of your data set, that is X train and X test why train and why test. Okay, why it is important? Because in see Python programming or even programming, everything is a mathematics is behind it. It's not like it's a person and it's telling something. It will always give you results in the form of a mathematics computation. So in matrices, there's something called matrix multiplication, which have a some restriction, which is like if A cross B and C cross D, or let's take it as in a simple way. If there are two matrices A and B, if I need to multiply them, A cross B, then their dimension should be same. Okay, or at least the column of A and row of B should be same, which means if A have 3 cross 3, then B must have 3 cross something. So this row and column should be same. So this is how we do a matrix multiplication. So for that, we need to know the shape. Okay.
Excuse me.
Yeah, please.
Here I want to ask something that in 21,
Yeah.
you have written that in first step you are printing training from training data set shape,
Yeah.
and from the next line you are printing from the test data shape.
Oh, this is just the shape. I just wanted to know. I have
Mm-hmm.
splitted my training and I have splitted my data set into training and testing.
Mm-hmm.
Okay, so that training and testing data set, what kind of shape it has? What shape means how many rows and column does it
Yeah,
have?
that I got it. That I
Yeah.
got it.
Mhm.
But I'm confused that in one in first row you are taking training, then test, then training, and then test.
You can take it as training and training itself. X train,
Okay.
Y train,
Okay. Okay.
not
Okay.
nothing.
Okay. Means you are giving print a 4 statement. That's why we are
Oh,
getting output 4 now.
yeah,
4 in 4
exactly,
rows.
exactly.
If we will if I will increase 2 more print statement, then
Yeah,
we'll get 2 more print
yeah.
statement.
Let's just
Okay.
remove
Okay.
them.
Thank you. Thank you.
Yeah, yeah. Okay. So here,
Hello, ma'am.
yeah. Please go
I
ahead.
have a question. In the previous example, you took that training 17th one. Go to 17th.
Yeah,
17th.
yeah. Mhm.
Yeah. Okay. Test size is 0.20. So
Just wait.
is
Yeah,
it managed?
yeah.
Is it
Please.
managed to take that test size up to 20%, or we can increase that value?
You can increase it, you can totally increase it, but usually we keep training data more and testing data less. So you can keep it in any ratio, 70/30, 60/40, 80/20. You can do it in any ratio. That's not an issue.
Okay. Okay. Thank you.
Okay, so that is all for today's class. I have used another model, that is like how I have used SVM, that is support vector machine. In this, I have just used k neighbors classifier. I just want to show you result for that as well. So over here, I'm getting accuracy of 0.98. Similar things. You will not get any difficulty in going through that. I have just mentioned it for to give more examples of that. Apart from that, everything I have almost covered for introduction to Sklearn. And whatever classification methods we have done over here, don't worry about this training, testing, and different models. We will come up, that we are three TAs, and we will come up again and again and again with all these models, predictions using Python. So today's class motive was just to let you know there's a library called Sklearn in Python, which have different kinds of Python libraries inbuilt, which have different functions which is required and which can be used as needed, like pandas, matplotlib, numpy. So this was just a glimpse of those kind of libraries, so that you would be familiar with those words. And when we will go in actual coding and different classification purpose and regression purpose modeling, you would be knowing these terminologies at least. Okay, so yeah, thank you for today's class. And if any question apart from that, please post it in the forum and we'll deal with that. Okay,
Thank you.
thank you so
Thank you.
much.
Thank you.
Thank you. Thank you.
Thank you, ma'am.